Welcome to the next GCSE chemistry topic. It's chapter 7, energy changes. Obviously this is the first time we've had to teach it this way. So we're going to go through the PowerPoint. You've got this information at home. I'll tell you to pause it at certain times, but if you miss something, feel free to pause, replay the video. Also, if there's something you don't understand, try and contact your teacher, any questions, and they'll get back to you, I'm sure, about that. What we're looking at today is exothermic and endothermic reactions. You may have come across these in your time doing chemistry and science when you were younger. And you may have an idea of what these words mean, because when we see the word thermic, what do we think of? We might think of temperature. What we're going to do today is investigate energy changes in reactions. Now, if I asked the year 7 what might happen in a chemical reaction, they would probably say, well, maybe a colour change, maybe a gas given off. Some of them, the bright ones, might say, well, the temperature might change. What they normally mean is the temperature goes up because they're experiencing reactions that have got hotter. But actually in chemistry, when there's a chemical reaction, the temperature might go up in a reaction, or it might actually go down. But regardless, there will be an energy change. You might want to highlight the first sentence. When a chemical reaction occurs, an energy transfer always takes place. Energy might be given out, and energy might be taken in. It says sometimes energy is given out from the surroundings, taken in from the surroundings. Get your words right, Mr. Boyle. Sometimes energy is taken in from the surroundings. Energy comes from the surroundings around the chemicals, the reactants, into them. Sometimes, though, energy is given out to the surroundings. You probably can already figure out what would happen if energy was given out. What might happen to the temperature if energy was given out? Well, when energy is given out, an exothermic reaction occurs. An exothermic reaction is one in which energy is given out to the surroundings. That's just me kicking the bin. Energy is given out to the surroundings, right? What do you think would happen to the surroundings if energy was given out to them? Have a think. What would happen to the surroundings if energy was given out? Now, an example of an exothermic reaction could be the combustion of a fuel, so burning a fuel such as methane. If we have methane and we burn it, what gas does it react with when we burn it? That's right, oxygen. What else is made when we burn methane? Well, I'm sure you all knew, you were all shouting out, it's carbon dioxide and water. But something else is also released in that reaction. We wouldn't write it on the equation, but energy is also released. Energy is released when we burn something. And that's an example of an exothermic reaction. Energy being released. This causes the temperature of the surroundings to do what? What would happen to the temperature surrounding the reaction? Well, the temperature would increase. So in an exothermic reaction, the temperature increases. So burning's a good example of an exothermic reaction. Other examples that we might need to know about, more specific uses of exothermic reactions, you may have heard of hand warmers. They have a chemical reaction in them. Hand warmers, that says. They have a chemical reaction in them that releases energy. The chemicals mix together, they release energy, your hands will then get warm. Another one, you might have seen them if you go camping, self-heating cans. So these are cans of food that have chemicals on the outside surrounding them. When they're mixed together, they'll react exothermically, they'll release energy, and they'll warm up the food inside of the can. So exothermic reactions release energy. An endothermic reaction then is the opposite. They don't release energy, An endothermic reaction is one which energy is taken in from the surroundings. Energy is taken in from the surroundings. That's quite a complicated idea to get your head around. Let's leave that on for a moment. Energy is taken in from the surroundings. It's difficult, this idea that energy is taken in and it goes into the reactants, right? There's not many examples you will have seen in chemistry, but there is a good one that you know from your biology course, which is photosynthesis. In photosynthesis, hopefully you do know this, I'm going to write it on you, but you already know it. We're starting with carbon dioxide and water. They're making glucose and oxygen. Right? That reaction won't happen on its own though. What is the energy that goes in to create that reaction, to make that reaction happen? Well, you'll know that the energy comes from sunlight. So this is an endothermic reaction that uses the light of the sun to make the reaction between the carbon dioxide and water happen. Now, you might not notice it in photosynthesis, but in general, it being the opposite of an exothermic reaction, in general, the temperature of the surroundings in an endothermic reaction, the temperature decreases. The temperature decreases. So in an endothermic reaction, energy is taken in and the temperature of the surroundings decreases. A good example of the use of an endothermic reaction that you see lots of people in this school worry, as they're always getting injured, the sports injury packs. You know, when you get hit on your fingers with a lacrosse stick, or the nurse will give you one of them packs, the chemicals join together, they mix together in the pack, they then get cold because they're taking in, and they can put that on the injured part of your body. Now on the next slide, we're going to look at an experiment that we can do to investigate whether reactions are endothermic or exothermic. What simply would happen is we would mix two chemicals together. How would we know if it was exothermic or endothermic? What would we measure? Well, we'd look at the temperature at the start and the temperature at the end. If the temperature went up, it's a exothermic reaction. If the temperature goes down and it's taking in energy, it's an endothermic reaction. So, you're going to read those instructions. You might want to pause the video. And there would be 4 experiments to do. Now, this table's been designed. It's not a great table. I'm not particularly happy with this. What is this table missing? We've got the reaction there, the 4 reactions that we're doing. What is this table missing? The first thing it's missing, obviously, is the headings. So we're going to have the temperature at the start, sorry about the small writing, temperature at the end, the temperature change, and each one of these, what will they also need? They'll need the units. Hopefully you will make yours look a little bit better. What do you think the final column is going to be for? That's going to tell us if it's exo or endo. So we've got 4 reactions: magnesium and sulfuric acid, sodium hydrogen carbonate and hydrochloric acid, magnesium powder and copper sulfate, potassium chloride and water. Obviously you can't do these reactions at home, but very luckily I think we had Holly, Emily and India film the video of this experiment, and that's going to be shared with you as well. And what you're going to do is use their results to fill this table in. So you're going to look at the other video and fill this table in. How will we know if it's exothermic or endothermic? Well, if the temperature goes up, it is exothermic. If the temperature goes down, it is endothermic. So I want you to pause this video now and watch the video of that experiment. Well, welcome back. Hopefully you watched that video. I'm very impressed with the practical skills. I know I was. Now, you'll notice that 2 of the reactions were exothermic, 2 of them were endothermic. The 2 that were endothermic, the temperature went down, didn't go down, that's me kicking the bin again. The temperature went down, didn't go down massively. The endothermic reactions that we often do in school, there's usually only a very small temperature change, where the exothermic ones had a much bigger temperature increase. But we did have 2 exothermic and 2 endothermic reactions. What I was disappointed by on their video was the lack of stirring. So you have to use your imagination now. They didn't stir the mixtures as I intended. It wasn't perfect. Why should they have stirred the mixture? If you're measuring the temperature at the start and at the end, and you want to measure the temperature accurately or something, why should you stir the mixture? Think about when you heating up a tin of soup and you have it on the pan, it seems hot, it's the smoke coming from it, you taste a little bit of it, it's, oh yeah, that's steaming, that's good soup. You pour it out, you sit down, you take your first spoonful and it's cold. What have you not done to the soup? You haven't stirred it properly. You must stir it to get the temperature the same throughout. So if we want to measure the temperature, it's got to be the same throughout to get an accurate reading. So why was the mixture stirred? Well, should have been. So the temperature was the same throughout. Or you could say, so the energy was transferred equally around the mixture. 2 of the reactions were endothermic. They took energy in. Where did this energy come from? Where did we say this energy came from? Well, we said it came from the surroundings. And that's why the surroundings got cooler. The surroundings were losing energy and it was going into the reaction, so the surroundings got cooler. Number 3, how could you make your results more reliable? We have to know, in any experiment, if we want to increase the reliability, what do we need to do? We need to repeat and take an average. We'd also, if we repeat, we'd also remove anomalous results. We could remove the results that didn't fit the pattern. We could remove any anomalous results. If you look to the experiment that the girls did, how could a lot of the heat from the reaction escaped, and we were doing it in a test tube, so it wasn't perfect, but if we wanted to do it in a more controlled environment to get an accurate measurement of the temperature change, we could probably have it we could do it in a beaker, or even better, a polystyrene cup, and also then we could use a lid. If we used a lid, then that would prevent the heat escaping. That's a very brief introduction to exothermic and endothermic reactions. Sorry, there's an extension activity at the bottom of the sheet. That would be very interesting for some of you to look at chemical hand warmers. Now, what you're also going to do now, you've got the exothermic and endothermic reactions homework. You can start that, and then you'll get the answers to that sent to you as well. You can mark that. Any questions on exothermic and endothermic reactions, feel free to contact your chemistry teacher. Thank you.